Right, a quick revision of what all we learned in OSPF. There may be here and there some new things. When we go through this, all those things will be covered. Introduction to OSPF protocol. As we know, this is a link state routing protocol. Only by collecting the link state advertisements, the routes are determined. That's why it is link state routing protocol. Repeating again, based on the link state advertisement, the routes are determined. So every router will not advertise. So no routers will advertise their best route. No routers will advertise their best route. Usually, in distance vector protocol, we see the routers will advertise the best route, including BGP. I'm talking BGP, though it's a path vector routing protocol. Uh, every routing protocol except this link state routing protocols, like OSPF and ISIS, all other protocols, they advertise their best route only. Best route only. If a route is not seen in the routing table, they will not be advertised. See, the routes may be seen in the database. The routes may be seen in the database. Links to the OSPF, BGP's forwarding table. The route may be seen in EAGRP topology. The route may be seen in RIP's database. But only the elected route will be forwarded to the routing table. And that elected route in the routing table will be advertised to the neighbor. Whereas in ISIS and OSPF, every link status is advertised. Very important difference. Not the routing table, but the link status. So when all the path information, when all the link status is advertised, when all the link status is advertised, the routers are able to learn the complete topology. Every roads in your city is being given to you, which means what? You can learn the complete city map very well. So using the map, every router position themselves in that map and find the best path, the shortest path, the low cost path to reach destinations. The cost is calculated as per the bandwidth of the link. More bandwidth, less the cost. More bandwidth, less the cost. You can also configure cost on the interface manually for OSPF to use. So we have the cost, which is auto, calculated based on what bandwidth you have. You also can have your own customized cost, which will be used as a metric to calculate the best path. So OSPF has got this flexibility of you determining what path to use. If you prefer a path over the other one, then give low cost to the preferred path. Don't care about bandwidth. Even if it is small bandwidth, the path will be preferred because you have given cheaper cost. So that route, based on your cost that you gave, is going to picked up by this algorithm called SPF. SPF algorithm picks up that low cost path. The cost may be auto, the cost might have been maybe you given. That doesn't matter. It uses the cost in whichever the form it is, whether it is manually given or auto calculated as per the bandwidth. It uses the cost and find the shortest path to reach destinations, and those paths alone will be seen in the routing table. So in the linked state database, you'll have all path information. There are three type of table. When OSPF can form a neighbor successfully by sending hello packets, if the hello packet parameters are acceptable, the neighborship comes up. Those neighbors are listed under neighbor table. The neighbor address need not to be the address from where the packet comes. The neighbor address is usually the router ID. So we all know OSPF uses loopback interface address as the router ID. So the source of the packet may not match with the neighbor address in this table. For example, when I have 10.001, 10.002 and loopback as 11111, other protocols like EIGRP or BGP, they all show this address in the neighbor table. And BGP will show this address and it will say that neighbor's router ID is 2222. Whereas OSP will show two 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 as a neighbor. But what is the source of this packet? 10002. Packet is coming from 10002, but that is not shown in the neighbor table as a neighbor. It's only the router ID. Because router ID is what used as an identifier to identify a router in a OSPF domain. And the topology table is going to have type 1, type 2, type 3, type 4, 5, 6, 7, 8, all LSAs that you want will be listed, those advertisements. Within an area, the topology table is going to be identical, same, similar. Again, it's only within the area. So don't expect the database to be universal, to be same all across the autonomous system, OSPF domain. You know very well, this is not a new class, this is a revision class. You know very well, type 1, type 2 of one area will never go to other area. So you cannot expect the database to be similar across the OSPF areas. Database is only identical within an area. Routing table will have the elected routes for every destination. Now, why link state routing protocol important? What is special in this link state routing protocol? Because link state routing protocol advertises the link state, all the links and their status, their bandwidth, their subnet, the cost on the link, the neighbor reachable via that link, those things. Because the link state advertisement is distributed to all the routers along with the router ID. This router can provide a full picture of the topology. As a result, when a primary path goes down, immediately you can swap it with an alternate path because your database have got the full picture, not partial. If you take EIGRP or BGP, you'll have only partial topology because only the best routes are advertised. I'm including BGP. Only the best routes are advertised. Whereas in OSPF, the complete picture of topology is used. This is the reason why, when we do traffic engineering, we always go with link state protocols. Because for traffic engineering, you need to know the complete city map. Only then you can be a very good traffic police. So the link state routing protocol providing full picture makes this routing protocol the best compared to any other protocol. It can take accurate path selection because it has got the complete map, and the switchover of path when a primary fails is more faster because there is no need to query someone if path fails. When a path fails, immediately it looks for alternate path. If it is available, uses it. If there is no alternate path in the database, what does that mean? It means that there is no path exist. But in EIGRP, that is not the case. If the primary goes down and if there is no backup in the topology table, then EIGRP is going to query and get struck inactive SIA. I tell you, OSPF is the best protocol, the protocol that can make very fast decisions, accurate and fast decisions. We got hierarchical design in OSPF. The reason is when you have hierarchy design, you get control over the topology. How? If any change happens in an area, that change will impact only the members of that area. Because you got a summarization point called ABR, where we will do summarization or we do sub configuration. As a result, the flooding of LSA is localized within an area. More you flood, more you disturb other areas. When we localize the flooding, within an area, the other areas don't get disturbed often. The bandwidth in the other area is also not consumed unnecessarily. So the efficiency of the total network is going higher. See, the advantage of having multiple areas. You can summarize all area 1 network in the border ABR. So that whenever a change happens, it will not be flooded everywhere. It will be flooded only within the area. Or you can configure stub because you already know stub. Because you got multiple area, you can say this area will be stub, that area will be not so stub, this area will be totally stub, that area will be totally not so stub. So if you don't have areas, you can't do this. It will be like one big bunch. You will not be able to set some policy for one particular area. See, the policy is easy to achieve here. Just creating some stub or something like that. Summarization. Areas are good. Okay, the area 0, which is mandatory, because without area 0, non-backbone areas cannot distribute routes. Area 0 is a backbone area. So all now non-backbone areas need to go through area 0 in order to distribute route. Why? Can I have an area 1, an area 2? These two routers, can they form neighbor and distribute routes? Not possible. Why not possible? They will not even form neighbor in first place. This hello packet will say I belong to area 1. This hello packet will say I belong to area 2. Aha, how it is going to be a neighbor when they are not identical, when they don't match the area. The hello packets, when they send, the area ID must match to accept them as the other one as a neighbor. Area ID should match, which is not matching. But when you have an ABR, an area 0, this router here will say, hey, I am area 1. This will also say, hey, I am area 1. And here this will say, I am area 0. And here this will say, I am area 0. They form neighbor here, they form neighbor here. This is area 1 relationship, this is area 0 relationship. It's the same OSPF, process ID 1. So OSPF is designed in this way. If you have on the same router area 0 and area 1, then you can give the routes to area 0. If you have on the same router area 2, not allowed. Area 1 cannot give route to area 2 link, but it can give only to area, it can give only to area 0 link. That is how it is designed. So all should go through a backbone. And if the backbone is not high-end devices, then it will be a difficult, right? If every area sends all the routes to a backbone, then it will become too busy, right? So to avoid that, we need to do what? Summarization. Summarization reduces the amount of LSAs that will go from one area to backbone and from backbone to other area. Summarization is important. So ABR is the summarization point. We need to do summary. So why do we need areas? So that you can minimize the size of the routing table by summarizing. You can localize the change that happens within an area. The detailed advertisement of LSAs are stopped in the boundary. It is not flooded or throughout the autonomous system. It is localized within the autonomous system. What is an autonomous system in OSPF? Multiple areas connecting through one area 0 is what? An autonomous system. Many areas, many non-backbone areas connecting to one backbone through one backbone area to form a group which will be under a single administration is an autonomous system in OSPF. So CDE are the Border routers, these are the summarization point. Now, hello packets in OSPF are very important. Everything starts from a hello. It is not link state advertisement. Link state advertisements are sent only after B accepting A as a neighbor and A accepting B as a neighbor. Listen carefully. LSAs are not going to help discover neighbor. It's the hello packet. LSAs comes later. First, these routers need to identify the other routers as neighbor. For that, they share the hello packets. In that hello packet, when certain parameters matches, only then those routers are considered or declared as neighbors. Parameters such as area ID, uh, the subnet, means this and this should be in same subnet, and then authentication, if you configure or not, authentication type should match, at least type 0. I explained you in the previous class. And then if authentication is configured, then authentication string, stub configured, that also should match. What should not match is router ID, should not match. Neighbor list won't match. All right, so these are the things that is shared in the hello packet. So certain parameters should match. After checking those parameters, it declares other routers as neighbor. So it is the hello packet that helps to discover neighbor. In both broadcast and point-to-point network type, OSPF network type broadcast and point-to-point, the hello packets are sent every 10 seconds. If neighbors stop saying hello packet after forming neighbor, the neighbors keep sending hello packet every 10 seconds. If they stop sending hello packet after 40 seconds, the neighbor which did not receive hello packet will discard the neighbor who did not send the hello packet for 40 seconds. So we call it as a dead time or hold time, 40 seconds. Again, as I just said, we have a point-to-point network. We have a broadcast type network. See, LAN is considered as a broadcast domain, broadcast. So when you have two routers connected back to back like this, we call it as point-to-point. When we have something like this, we got multi-point or broadcast type. In this, there will be a DR-BDR election. In this, no DR-BDR. So during the adjacency process, there will be master slave and point-to-point. After that, no master, no slave once the adjacency is established. And we all know the DR-BDR election process. The router with the high priority becomes the DR. To configure priority, you need to go to the interface and say IP OSPF priority and give a number. Maximum is 255. The default is 1. You can also make it a 0 if you don't want a router to participate in election. In a point-to-point environment, the default priority is 0. There is no use of you turning on this to 1 or 255 because there is no DR-BDR election. They don't care about priority. The point-to-point networks, they don't care about priority. Now, in a link state routing protocol, full adjacency will be formed with DR. So every other routers will have full adjacency with DRs. When I say DRs, it includes BDR. Between the others, they will have only two-way relationship. What does that mean? With DRs, they will share every changes that happens in their environment, and it is only the DR will take update from one other and give to other router. This avoids duplication of update, which in turn avoids loop. We have learned all these stories, but still if you have questions on these things, you can ask, I'll explain. So two-way relationship routers will not exchange any DBD. Two-way relationship routers will know them as neighbors, but they don't do any exchange. And we know that SPF algorithm is also called as Dijkstra's algorithm because the man Dijkstra is the one who proposed this SPF algorithm, shortest path first, the binary tree algorithm, which is used here as a routing protocols algorithm. OSPF is a routing protocol which uses that algorithm called SPF, which was proposed by Dijkstra. So this algorithm can calculate the path cost and pick the best path as the low cost as the best path. That's the idea behind the binary tree algorithm, Dijkstra's algorithm. Pick, choose, low cost path as the best path. So the link state advertisements that are shared between the neighbor are stored in the database, and the database is referred by this OSPF algorithm to find the shortest path for each destination, and the elected shortest low cost path is considered as the best path installed into the routing table. And this is the explanation how binary tree, how SPF calculates the path. Considering each link cost is 10, considering each link cost is 10, if you see cost here is 10, every link is 10. If I want to go from X to F, taking this path is cheaper because it is 10 plus 10 is 20, rather than taking 10, 10, 10, 10, 30, or 10, 10, 10, 30. So going straight from X to D and D to F is the best. Okay. So the low cost path is calculated by calculating the path cost. Now, how the database is updated? Let's say a router is receiving an LSU, means DBD, with a sequence number. First of all, it will check whether the receiving router will check whether I have a database. There is database, but there is nothing inside it. There is nothing inside it. There is no data in the database, which means whatever comes in is the first update for this router. Whatever the sequence number, that doesn't matter. But this is the first time you are receiving something. So add it to the database. Send the acknowledgement to the sender who sent it. And then flood this information to the downstream. Means your own neighbors. You receive from upstream, you are flooding it to downstream so that they also will know about this. And then run the SPF on this database, put the best path into the routing table. The process ends. But what if I already have an entry in my database? My database is not empty when I received this update. It has got already something in it. Then what I need to do is the sequence number that is coming, let's say sequence number is 50, then local is 45. Is the sequence number same? Of course, no, it is not same. Okay, is the sequence number coming as higher? Yes, means I need to add it to the database here. A. And repeat the same procedure. Send the acknowledgement, flood it to the downstream, run the SPF, and in case if the sequence number is same, which means I already have the update. Let's say I'm also having 50 incoming, then ignore it. In case if the sequence number that I have is higher, the incoming is 45. The incoming is 45. What I have is already an updated one. Incoming is not higher. Then I have to intimate, inform the source who is sending this with my update. Hey, you got an old one. I have a better one. See, OSPF is smart. Right, one small information that you may not know is OSPF has got both incremental update, which is going as a triggered update. Incremental update means what? Only the change that happened will be flooded to everyone immediately. Along with that, it also sends a periodic update. Whether change happens or not, the complete DBD will be sent to every neighbor every 30 minutes. You see, so we have both. You should not forget this. Every 30 minutes, it's not every 30 seconds. See, in RIP we saw every 30 seconds it sends periodically updates, so RIP is bad. Because every 30 seconds it is going to consume data space. Now, the other things, two-tier architecture, hello packets, Dijkstra's algorithm role. Okay, when the packet is sent with an update with a sequence number, that update is not going to be forever with the same. Actually, what I'm coming to say is it will run clock. The reason is after 30 minutes they have to refresh. They need to send the entire database once again to sync to make sure that everyone is in sync. The periodic update is there, so they need to. It needs to age out. Plus, every 60 minutes, every hour, the sequence number need to get resettled. We'll talk about that in the next chapter. It's coming in the next chapter about the sequence number and all. So when I receive an update, immediately the clock ticks. It will show you you have this update for last 50 seconds, 300 seconds. It will show you the timer. All right. You can see them in typing show IP OSPF databases. Type 3, type 4 LSS, type 1, type 2 LSS. It will show you age, sequence number, everything. All right, so this is the end of the first chapter.